YouTube. Hey guys, welcome back to a new stream. Today I'm gonna solve some problems on dynamic programming. I have been doing problems on subsequences. It is quite interesting. Let's start with some typing. Okay, let's do that. Do that first. Okay. Call. Okay, so what's the problem is that I am making so much mistakes. I'm not accurate in typing, which making me slow, and it also difficult to type when you're looking upward from the second monitor and typing in the laptop. What I'm doing. Ah, what? Uh, what is that? After completing a word, if I made some mistake, uh, then it also give a one mistake or error. Like that. That's what I'm talking about. I have to be very slow. I don't know why. Okay, now what will do, if I made some mistake, I have to correct it before moving to the next word. That's not gonna happen. What? Why my hand not taking the listen, I have to change my position. I guess that will help. Only be back. No way. It's going very well, but at the end I made a mistake. Stand. Okay, so no, no. Large may face, few can't face. Even a single letter I can't type. Get. Oh no. Line. People. Oh, shit. That's what I'm talking about. If you don't correct the mistake, then it will also give an error after the completion of word. Let's see how fast I can now. Why? Okay, my boy. Why I have made mistake again? That's a simple word. State. Why I couldn't type the T? Consider between another small. That's a sin, bro. Increase, say, into get. I mean, who make mistaking person. Turn have like person. I guess that's a quite an improvement from the starting. Uh, Give me a minute. So what I'm doing? I'm making slow, uh, writing a one word at a time. I'm who No way. That's a 2 error. Not bad. That's a 3 error. Oh yes, I should say mistake. What I'm typing. No way, I skipped that. If I go without the proper attention, then that's where the error comes from. Like I'm focusing very well how I am typing. Okay, around 51%. Okay, so let's review the previous question before starting any further. So what question is that? 416, what it tells us partition equal a subset sum. So it's a similar question to previous the first question we have uh, done in the subsequence part of DP, where if I am recalling correctly, where we have to find the sum of the subset with a sum k. Okay, so in a array we have to find the subset that equals to the target sum we have given. Yeah, that's a question. Okay, so before starting, first I think that's the first time we have submitted. One, two, three, four means okay. I guess that's first time we have submitted, I guess. No, no, this is a. So what the question states that given an integer array nums, return true if you can partition an array into two subsets such that the sum of elements in both subsets equal to the false otherwise. Okay, so what it tells you that you have to equally divide the array into two subsets into two subsets like that they have this similar sum or the same sum in both the subsets. Okay, like in this example we can divide the subset like 11 that is one subset, and 155 that will be 11, and that is the second subset, and that gives the equal sum. So we can return true because both the subsets are returning the same have the same sum. So that's a question. And what we are doing that in recursion, we can solve this recursion. In this the greedy approach can't be work because we have to calculate every uh, what I call it, every subset. We have to find every subset in the array that can be formed through the array, and check for that. So we can do the recursion by checking one by one all the subsets and their sums equal whenever they are equal. That's a main object main approach. And also, so this question is about the sum. Both the subsets are they have the same sum. Then what we have done, we have find the total sum and divide it into two, because if we want to have the same sum, then the sum will be the total sums half, and the total sums half is act like a target sum that worked in a previous question. Target okay, so that's the target sum is a total sum half, and we will check for the subset that any subset in the array in the any subset array sum and that is equals to the sum. Okay, so and there's a condition condition we can find that if sum is odd, then can't be divided into two subsets. It's obvious. And then we will further solve the problem whenever the total sum is even, and we will find the subset that have the sum equal to the half of the total sum, and that will be the, and if we found the sum, then we can show that that subset is one of the half sum, and the other half is also equals to the sum, total sums half. Okay, so how we have solved it? That's the first type. This is a recursion, and we have created a DP to convert into memorization. First we have calculated total sum, and then the find the sum, total sum, or the sum, the target sum, and the target sum, and we have created a vector of the n row and sum plus 1 column. And why we have done sum plus 1? That's a like okay, because sum plus 1, because sum is the total of sum is the target sum, and which is starting from the 0th. So we have to add one more index for the column, and then we have written the subset present, and that the function, what the function is, that there is a these are the base condition, 3 base condition. If sum is equals to 0, if the sum is equal to, then return false. No. Okay, so we are not going to return false, we are going to return true. That's a mistake, because if sum is already true, if sum is 0, then it is true that we can't divide. And okay, so for the next for the base condition with the 0 index. For the 0 index, what we have done, okay, so okay, so this is a condition. Whenever we already traverse all the array sum, and we haven't find the subset sum, and then the last element remain, and then we will we can give that value, the index 0 is equals to array of sum. And that is the condition for DP. If DP is not equals to -1, then return DP, because that's a overlapping condition. And here we have solved the take or not take. The not take condition, subset present. Okay, so not take condition, if that we will not include the array in array value at that index, and but we will increase the or decrease the index. And for the take term, we will set it to false, because we will to change it. And if the array index is the array index should be lesser than the sum, target sum, because if it is greater than, then we can't include in the subset. That's the take. And the subset preset, and then I can do that. What I can do, increase the index, and then reduce the array index value from the sum. Okay, and then return the take or not in anyhow. And for the tabulation, that's the same procedure. Here we have created a vector with a bool because we don't need to create an integer, and we have given the target sum. First, for the base condition, what will be the base condition? Like TP is true. If the what will the base condition means that the zeroth, whenever the sum is target sum is 0, like in the previous base condition, if the base condition is not the base condition, if the target sum is 0, then you don't have to uh, check for the correct subsets, then you can directly return the value is true. So that's here is also a way of base conditioning. Like for the for the first column, the zeroth, whenever the target is 0 sum, then all the columns we will all the columns of the the first column of all the rows, we will uh, convert that into the true. That's the base condition. And now for the because the tabulation is a bottom up approach, we will start from the bottom, then we will give the dp0 is a true, because that's how we're gonna find. And we have to check the condition if the target sum equals to array. If target sum should be lesser than the array indexed of the zeroth value. Okay, so now okay, then we will use the for loops. That's the procedure I have been following for the solving the dp. And first is the dp index up to n, and for the second is the target sum, because second target, what I can do similar to that's a similar procedure we have followed in the memoization, but in this case we were just using the for loops. And we will take, if the take dp index -1 and target, because in this what in this step we will not including the array value, then I will just forwarding to the next index without including the subset, the array in the subset. And that's the second case in which we will take the array, and here we checking the condition for the array value should be lesser than the target sum. That's a boundation condition. And here we have here the take condition, in which we have I have increase the index, because the index and then and we will reduce the target sum, because whenever the array is included, the array value is included into the subset, then we will decrease the target sum that we have to find, and the tp, and then we will return we will give the value to the dp, because we have created a dp of the size index and target, and we will give the value to the index it is true or not true for the overlapping conditions. And in last we will return the last dp, because the answer is present at the last row of the DP, because uh, tabulation is a bottom approach. Okay, so we have the gist of the problem. Now we will try to solve some new problems, and let's do that's a hard problem, normal that, but we will try to solve that. Okay, so okay, so now in today's uh, I have attempted today's concept, and I have solved 3 questions, but I have taken a hint from the some in third question, not the third question, the second question. The third question is quite easy in comparison to, I don't know about the second, and but this is the this is the first. That's for the flag, it's active or adding or not adding. That's a that is that question. And dictatorial permutation, that's a question. And in the zor element, we have to reverse the string t, reverse the string tree, so that the s and t gives the maximum output. That's how we have to arrange the string. What I done, count the value of zeros 1, and arranged by the string as if the in a appropriate maximum value that can be formed by this reversed t string. Forgot about that. Let's go to the question. Okay, that's the problem I'm gonna solve. So what have we here? All the TP question are gonna be a hard question. That's a tricky one, because lead code hearts are hard. Assign cookies, let's check that. Easy. Okay, coin change, target sum, coin change 2. Okay, that's I think that is enough. Unbounded knapsack. Okay, knapsack is a good question. Oh, that's a lot of question I have to do. I think I have to do. Let's check this. What this question is studying: partition array into 2 arrays to minimize. Oh, I have done that question. I think I have copy paste it of the some YouTuber. I don't know about that. Like what I have attempted in 2024. That's a 2 years ago. Partition array into 2 arrays to minimize some difference. You are given an integer array nums of 2 uh, 2 into n. What? Read carefully. You're given an integer nums and of 2 into integers. You need to, okay, so size is the 2n. You need to partition nums into two arrays of length n. Okay, we have to divide two arrays into size n, and to minimize the absolute difference of the sums of the array, uh, absolute sums. Okay, I got it. The partition nums, put each element of nums to put each element of nums into one of the two arrays. Return the minimum possible absolute difference. Minimum possible absolute answer means the answer will be positive, but the we have to return the minimum we can minimum difference we can get from the two by creating the two. Like in previous question, that's opposite of the previous question, but that is this is different. Like I have done in previous question, we have to I have to done the find the sum total, half of the total sum, that will work as a target sum. But in this case we have to get the minimum difference, and in last question I have just divided the total sum, and I get the half sum. But how can I here get the minimum difference? That's, if I got the minimum difference, then I can be able to okay so let's check an example. That's an array 3 and 9 nums. What? Okay, that's an array nums. We have given 3973 and array in this example, partition is done of these two, 3 and 9 and 7 of 3. Okay, and if we add these numbers, 3 9 12 7 3 10 and 12, absolute of 12 10 is 2, and the optimal partition is 3. Okay, so there is no other way. Yeah, if we take 3 7, that will be the same. 3 3 and 9 7 16, that will be a 10. That's not the minimum difference. And here we have minus 36 and plus 36, and that will be okay, that will be 72. The optimal partition, yes. Okay, that's example 3. Now how? That's 2 minus 1 0 4 minus 2 minus 9. If we 2 4 minus 9, that will be minus 3. Minus 1 0 minus 2, that will be minus 3. Minus 3 minus 3, and the addition and the difference of both is 0. Okay, so the minimum will be 0. I think I won't be able to solve this question without getting the help of something. Acceptance range is 23%. The target sum of the two particles is sum. Two partition is sum. What? Could you reduce the time complexity if you ultimately divide some nums into two halves, two arrays meet in the middle? Suppose has be calculated to the array where the kth index will store all possible sum values if only k elements from this, and for each element of the sum. Like, and if we get the total sum of all these numbers 3, 9, 7, 3, 12, 19 and 22, if we divide all the numbers by 2, we will get 11, and it is pointing to something. I don't think so. That's not minus 36 plus 36. Add both of these and 0. What this hint one says: sum of nums divided by the target sum for two partition. The target sum will for the two partition will be nums, the sum of nums, and divided by 2, and three plus 9, 12, 12 divided by 6. If I could, yeah, minus sum makes it difficult. Like, the okay. Let's forget about this question right now. We will solve later on. I'm not preparing for that big company that gonna ask that hard question. But they ask these questions for the 4LP also. Count subset with some k. Okay. Count subsets with some k. Do we have this question in Leetcoding? Count subset with some key. That's the question. There's on key 0 sub-array sums equals k. No sub-array, we have to count the sub-arrays. Given an element, we solve that question previously. Dang, what is this question? If it's just similar to that previous question, then we will gonna skip that. If it has some things to learn, then we will see. Okay, so count subset with some k given an array of n integers and an integer k. Count the number of subsets of the given array that have a sum equals to k. Return the result modulo. Okay, so we have to calculate all the subsets that have the same that have the sum total sum of that subsets is equals to the target sum. We have to return the count. Like in this, we have the total sum is count, and we have to find all the subsets. Like just take the recursion and just take the recursion and find out all the possible subsets and check if it is equals to 10. Then if it is equals to 10, then increase 1. If it is equal to 10, then return 1. That's a way. And how we possibly can find all the subsets. We will be first using the recursion, then memorization, and in last we will use the tabulation. Output. Okay, let's take take this example. 2, 3, 5 and 5, that will be 10. 1, increase the counter. Okay, 2, 3 and 16, no. 2, 3, 8, no. 2 and 8, 1 is that. 10 and 10 also, that's the 3, and I can't see any other possible subsets. Explanation. Okay, that's the okay. Okay, upgrade to submit. No need to submit. Let's close this. Not the editorial. Oh, where is this question suggestion watching a video? What? Okay, let's try to solve. Like similar procedure with this question. We will follow the similar path, but in the case we are representing we are returning the true or false. But in this case we will what I gonna do, I gonna return the counter. I will initialize the counter and increment every time that we found the subset with the sum equals to k. Let's see the solution. We don't have any way to practice it. Just like that. Okay, that's our given function. Nums and target, we have given target. We have initialized vector with the size nums of size, the row size of the array. size, and the target plus 1 minus 1. Okay, we have to return the target plus 1 because we have to get to the zeroth zero target value should be 0, and we will returning the sum. We will return the function, and the here we have the page condition. That's the same condition. Target 0, return 1. Return 1 means only the one way you can get the target is because the target is 0 and you have found it, then return 1. And for the next, that if you are at the 0th index, and whenever then you have to find the num 0, then you will return. If you found the num 0 is equals to target, then you're going to return 1, or else you will return 0. If already computed return from DP, that means that's a overlapping condition that we have solved up till now, and that's a take and not take condition. Not take means we will not take, just we will take is the counter, and in this take we will take the value, and we have all also okay, that's a similar, and every time we have found the value, we will return 1. So we will return the take plus not take, just like that. Count partition with given difference. I think that will be a similar question, because I can assume that this question is telling us that this is providing a difference, and we have to find the subsets that have the same difference, means the same target, or the difference we have to subtract the subtract the arrays in one another, then we can find the approach. Yeah, I can see that, like similar question that parent the count partitions array D. Function to count a partition with given difference. We have given the array and the difference and the total sum. We have got the total sum of the array. Check the total sum is available. The total sum plus difference divided by 2. What that means? I haven't read the question properly. Just forget about that. Let's go to the assign cookies. You don't have to solve many questions, just have to learn the concept. 445 question. What is that question? Assign cookies. Okay, this question is same as maximum matching of players with trainers. Got that? Assume. I haven't solved that question, I think. Yeah, we will check it out also, this question also. First we have to take care about the assigned cookies. Assume you are an awesome parent and want to give your children some cookies. You have to be awesome parents to give cookies to your children, but you should give each child at most 1 cookies. Okay, you have to give more than 1 cookies each child at most. You should give each child at most, means you have to give only just one. You can give one or not give, I think. Yeah. The threshold for the cookie distribution is 1. Each child I has a grade factor. Okay, greed factor. What? Each child has a greed factor zi, which is the minimum size, of cookie that a child will be content with, and each cookie j has a size. Okay, this is the size of quiz, and size of quiz will be greater than equal to the. Okay, so these two arrays have the one. The gi represent the greediness of the children, like the size, that is so helping us to solving the what size we can, what size of cookies we can give to the children, and that's the size of the cookies. We can assign the cookies j to the child I, and the child I will be content. Okay, I is the child, j has the cookies, will be your goal is to maximize the number of your content of children. Okay, that also maximize means have heard. Your goal is to maximize the number of content children and output the maximum number. What's up with this description? They have to be clear. Okay, let's the examples helps a lot in understanding the question. Without the test cases we can't understand these most of the descriptions. Z 1 2 3, C 1 1. Okay, so greediness of the children is 1 2 3, and the size of cookies is 1 and 1. Got that? 1 and 1. Explanation. And the output will be 1, means what? You have 3 children and 2 cookies. The greed factor of 3 children are 1 2 3, and even though you have 2 cookies, since their size is both 1, you could only make the child whose greed factor is 1 content. Okay, content means that you have to fulfill their desire, and each cookie we can assign the cookie j to the child I, and the child I will be content. Your goal is to maximize the number of your content children. Okay, you have to provide the cookies exactly the need good greediness of that children. That will be counted as a content. If you okay, since their size is both 1, you could only make the child whose character is 1 content. You need to output 1. Okay, also we can do 1 1 to the second, but we can't make 2. Okay, so in this example we have two children. One is having the 1 greediness, second is 2, and we have 2 cookies. Now we can get the 2 content. We can get the maximum content is the number of children present. Okay, so we can give 1 to this and 2 to this one children. You have 2 children, then 3 cookies. The greed factor of 2 children are 1 and 2. You have 3 cookies and their size are being big enough to gratify all the children. you need to output 2. I think that will not be that should not be a easy question. That should not be a easy question. I don't know about the tag. I don't know about the tag of the lead code question. So, what should I do? You have 3 children. 2 cookies. Can I do give the value of greediness to 1 by 1 to the size, the cookie array, and then find does the count 1 by 1 the content we can fill the content the children's content, like like Okay, so what I was doing here, I was converting this problem that I've solved in memorization into tabulation. And to do that, first we have to make all the row which has zero amount. Then we will convert that dp of that uh, amount index is the largest value we can provide, that is 1 a9. And uh, now we have tested we have handle the base condition was 0. Now we need to check for the uh, index where for the 0th index for the base, because in bottom approach we know that the base condition is very important for the solving of the question. And here, and like in this question, the if the logarithm less than equal to, okay, so that is okay. So now we have to know this condition, how we can handle that. Like if the coins index am I getting called? Wait a minute. Like if in any point of time, like in the initial, the base condition where the index is 0 0, the coin value is less than the amount. Okay, so this condition is that you are on the last index. uh, After that there is no coins to solve or they use. So you are counting, you are assuming that this will be the only coin that can give the solution. If this coin should give the solution, then how much that the solution with at the dp, that will be the okay. I think that will be amount like we have done in here in this condition. The amount okay, as that is 0. I think we don't have to check this condition at the index 0 and the amount of coin 0. Do we have to check this also? Like we already have the 0th position, and let's just do this. We will say the count of coins of 0. Let's see, and let's give the second iteration with starting with 0. Okay, we don't need to start from the 0th row because we have handled the position. And now the size of m is amount plus 1, and that way this amount j plus plus. Now let's take these conditions. I take or not take. What I will do for the not take condition, we will function we need dp, and the index becomes -1. Don't need dp. Do we need amount or the coins? Or we need the amount. Okay, and here we will do in place of that dp index same, because which can be again can be filled by the same coin, and the target becomes the lesser by the coins value. The amount minus coins with the value of coins at the position index. And let's do that. And after all this we will return answer, and answer will be the dp of dp of minimum, dp of minimum, not dp of minimum, uh, okay. So every time we have to also fill the dp. So how we will gonna fill a dp, like here. Okay, so now here, after getting the value, we will change the dp index. Do have to do that in yes, your amount will be the minimum of take and not take, and after that we will get the minimum answer as in dp, or where we will get our answer as a last, in the last index, like n minus 1 and the amount, and this will check for the condition. Let's run that, if it's gonna work. Okay, so it's 0, I guess. dp index minus 1, error use of undefined index. Okay, so here we have not initial index. Let's remove this first. Okay, so in place of index we have I every time. Okay, they're gonna take here also. I don't know about this test case. Okay, second answer is okay, but okay, every time we are getting the -1 answer. That is not correct. In any case, answer is not returning. Like dp of I, that is amount, we will not getting the value from the tag. Okay, that's the dp and the amount, and the amount is coin -1. I guess this is the correct way, but do we solving the previous position? We don't know about the test cases, and now we have been stuck the condition for we will not, I have not solving the condition correctly. Other than that, I have to take care of of the test cases. uh, but before that we have to solve the problems. -1, why we are not getting the output? Like I think I have done this problem wrong, because this db does not getting the value from the base positions of the db. If coins and zero are greater than, then we will return. I'm returning uh, this condition. But before that, okay, like this okay, I think let's try with 0, not 0, I guess 1 be what should be now. Else not the answer we're getting. Okay, change. Yes, that will be the maximum value we will getting if this is the correct. And if there is any way that you are getting another coins for the target sum, then this will be this will take by the minimum value of the take and not take, and that will be presented the dp amount I and the, and do we start with that one also here? I don't think that's it. So what I can do, find some hints from this solution. Okay, several induction based case mistake. I will explain why. I think that's major. Why would I need the maximum value for the minimum sum? That's a valid point. Okay, the first row, recognition is in the first row. The first row would be you must fill all the z values for row 0. Okay, I have to do this pro as well, like for every okay, this states that you have the same output. Okay, you have the different amount. Okay, that this is the condition we can solve like you have the amount differently, like in the rows you have different 0 1 2 3 4 5 6 7 8 9 10 up to the amount value, and you can only be filled this amount by using the first coin, the coin that is present at the position 0th. And if that would be the condition, is that if the initial the I, that is the amount we are taking in the first position, if is coin is modulation coins is equals to 0, means which can be sold by this, means you will get 0 remainder after this, then you can use that coin for the minimum amount, and that will be the position, and that will be the 0th row, but the amount will increase, and that is from I2, and the sum will be the ith, and that is divided by the coin 0, which means the coins required for to get this amount. Okay, so you're now filling all these row positions where you, for 0th row you need 1 coin, if you have 1 coin in that, or 1 for 1 coin, 2 for 2 you need 2 1 coin, 1 of coins, for 3 you need 3 coins of 1 value, and for 4 you need 4 coins for 1 value. That's how you will end up using this I divided by coins of 0, and if this is not the condition true, means that is not the if means you can't you can't solve problem using the next value, or means the coins that are present in the last row, then you will return the maximum value. That's, I think that's it for the row and column. They both are settled now. And now we will think about that. And here we are using J, so why we don't need amount. I have done the same mistake previously. I have to be careful about that. Just like that. I think that will be enough. Nope. Here okay. Yeah, and I guess I will no, I have tackled all the 0 previously. Then I will start from the 1, and this same with the row and row also. Okay, I got the sum answer, but 0 and -1 is correct, but I'm not getting the 3 by this solution. this condition is wrong here. Like this condition is telling that the coins you will using every time, like you, if you have the zero amount, then you will using first time the this coin, the first coin, like you have the coin the like these 1 2 5. First time you are using 1, then 2 5. But if you have amount 0, then you don't need to use any of these coins. How about that? No, true also. But that condition doesn't make any effect in that answer. The same. Okay. We go to go up to until the amount. Okay. Now we are talking. I have to very specific about the bounds. Wrong answer. Now what I have done? Okay. All right. Of course. Like what is the mistake I have done? I think that's the actually check the input. It's coins 1 and 2. And the output will be
無敵の笑顔だら